Okay, we are now live. Hi, everybody. Welcome to our Figure Friday session, week 33. I'm going to share a screen so you all can see the apps and the data and the graphs that people built. Figure Friday, there we go. Okay, you should be able to see week 33. There we have it. So week 33 is data set is on the class sizes in New York City schools. If we can go into the data right here, I always have the first link that'll take you into the data, and we'll have the reference, and we'll have like where it comes from, which I think it was New York City Open Portal. And then we have the data set here, which is a CSV sheet that you can just download by clicking this button. And so we have columns like borough here. Every letter represents a different borough from the 5 boroughs in New York City. Grade level, percentage of students, number of students, number of classes, and the class size. And then we have like core subjects as well. If we scroll down a little bit, that field starts filling up. There's some data there. So what we tried to do is answer questions like, what's the average class size? How does it differ between boroughs? How many students? And so on and so on. We have this sample Dash app with the Dash AG grid table, which is the Google sheet, the CSV sheet inside Dash AG grid. And then we have, I used here Sunburst. So it makes it easier to see with the colors, the class sizes of each per borough, per grade level. So we can see here how the smaller ones, oops, what happened here? Yeah, here we go. This first grade, second grade, third grade tend to be smaller classes, around 20 to 22. And then the higher you go, 7, 8, 9 tend to be filled up more, especially 7 and 8. Yeah, you see here 7 is like 26 in Staten Island. And that, you have to dig into that and try to figure out what's happening there. Why is that the case? Let me add here Alex to the platform. Hi, Alex. Welcome.
Morning, Alex.
A reason for that might be there's just maybe fewer high schools, middle school and high schools, than elementary schools. Maybe just we need to create more high schools, or maybe New York City has, the Department of Education is okay with having 24 to 26 on average students per class. So we have that, and then we have an image here of the Plotly Studio app that I created, the first 2 graphs and summary cards out of the 6 graphs that it created for me. And then we had Mike, Alex, and Esther that actually created a few visualizations and data apps. So I'm going to show, before I pass it on to Mike, I'm going to show what Esther, if this link is public, let's see what Esther created. And then we'll pass it to Mike and then to Alex. Esther did a great job sharing here the code as well, so people can learn from it, can copy paste it, and just use it in their own reproduce this locally, right? She's using Dash Bootstrap, which is kind of cool, a great library. And here we go. So she uploaded her Dash app to the Plotly Cloud. Anybody can join Plotly Cloud. You can open a free account. It's a signin.plotly.cloud. Let me just make sure. signin.cloud.plotly.com, and you'll be able to see this page. Well, this page is my apps, but you'll sign in and you'll have, if you're new, you'll have completely new 0 apps that you can create projects with. Okay. So NYC school class size, we have the summary cards here that Esther did. Records, how many do we have? 68,000. Total classes, 1,433,000. And average class size overall was like 21.6. And then she added 4 beautiful graphs here. A heat map that shows per year and per borough the average class size, which is similar to the Sunburst that I created, but probably easier to read through a heat map that Esther put here. You see, we have Queens, Manhattan is M. I think Staten Island was R. Bronx is X. K is Brooklyn. And here is the lowest one in 2012. Also, we saw some differences in data in 2012. There was a big drop. Maybe the data wasn't. Maybe there was something wrong with the data. Um, but it really cool to see how over, let's say just Brooklyn, we can see how there was a lot in 2010. The average was higher, and then this is just by several points, decimal points. But here it's lower in 2014 compared to 2010. Really clear here in Staten Island. It's 21.7. It goes up by a little bit, and then it just drops 21.2, 21.5, 21.5. So it never recuperated from 2010. What else do we have here? We have the box plot, the special education. And not a surprise that the average class size is smaller for special education, because generally these are students. The whole definition of special education is students who just need more more time, for usually from the teachers, and a little bit more attention. So either you have more teachers or you have less students. There's no way around it, and so that's probably fewer students here. The reason. And then we have here by other program types, right? General education. Forget what ICT stands for. It seems like this is the lowest compared to all the rest. It is not general education, special education. And then we have the dashed grid here, which we can use to sort, right, or to change. Maybe I just want to see. Maybe I just want to see X or R, Staten Island. And there we go. I just Staten Island borough. There's 3,465 boroughs. So, and then we have the controls here, which is pretty cool. If you wanted to limit it to certain things, in addition to these controls.
Adam, if I may add a comment, this is really an incredibly good dashboard.
You like it?
Yeah, I do. I like it so much. This was not Plotly Studio, right? She wrote that herself.
No, she made it. It looks like Plotly Studio, but Esther made this with
Dash App.
And that's how she actually has the code, because you can't really extract the code unless you make it a Dash app or you move it to a different tier. So here she has all the code. She might have created a proof of concept with Plotly Studio and then just recreated it in Dash.
That's something I want to migrate towards. I'm not there yet, but
really cool. Yeah,
I mean it tells me a lot of things I know and things I didn't know, but
yeah. Oh, Alex, your work inspired me to make a heat map too. Thank
you. Actually, Alex's heat map was also very, very good and very useful. And it confirmed what all of us are seeing, right? That there's 1 year where the data is low. None of us knows why. Probably it's a data problem. Hurricane Sandy came that year, but that wouldn't affect the whole
year. But that'll
be
like 2 weeks or so. So yeah.
Or maybe as I said, 6 months, because it's exactly half. If you look at, it's exactly half of the data of the other years. I don't know.
It's weird the data exactly by half.
Weird.
Like 6 months, like you said, Alex.
Yeah, but
it's really an anomaly, but somebody on the inside would have a clear explanation. I mean, we're not the subject matter experts. We try our best, but there's an explanation for it. It may just be the data wasn't collected fully, or
But this is the type of analysis that I like it to do. Basically, group by or pivot table, and also granularity to see exactly what is going on.
Right.
It's basically.
All right. Well, let's go to you, Mike. You had a nice application you built.
Yeah, and I have a little story with that. Let me go ahead and share. It's the plus button, right? Yeah. Okay. Share screen. Okay. Okay, you can see my screen, I believe.
Yes.
It's coming.
Okay. Not even sure I'm looking at here. Oh, sorry. This is my screen. And what I want to show you is that I did very little coding this week because I let Plotly Studio do all the work. And so I just want to show you a small bit of code that I used to clean the data. And one thing I didn't like about the data set is who knows that K means Brooklyn and R means Staten Island? Most people don't, I would say. So I put this, conversion in polars to rename the boroughs. Q being Queens, M Manhattan. You guys get the rest.
That's only Staten Island is road, right, Mike? To rename the boroughs.
Yeah, pretty much. I mean, I kind of made it a little more vertical for clean code, but yeah, that's all it is. And our, why is our Staten Island? It's actually New York boroughs are each their own county, and Staten Island is Richmond County, right? Brooklyn is Kings County. So that's where that came from. But most people outside of the tri-state area don't really know that. So
good to know.
So I threw that in there, much less outside the country. Yeah, and these are just some pipe commands where we had a discussion. There's a thread about, how did you get that number of total students? And I forget who posted that. So this code prints out the number of students as it moves through the data cleaning pipeline.
Nice.
And that was pretty much all I did. And then I threw this Parquet file into Plotly Studio. And Parquet is nice, by the way, because when you're up against, Plotly Studio has file size limits as everybody else does, and it's good to keep your files as small as possible, I would say, in general. So that was it. And so I ran in Plotly Studio. I didn't get a chance to customize it as much as I would have liked to, but it gave me these kind of typical graphs, like a box plot.
But so, Mike, when you did this, you told it. Most people will just feed it the data and just see what Plotly Studio gives them. Is that what you did, or you said, okay, I want specifically this graph or that graph?
I didn't name the graphs, but what I did was I took a cue from Chris Parmer, and on this board here, in addition to sharing like how I clean the data and all that stuff, I think it's good to include, instead of code on how to make a dashboard, because I don't have any, I said, here, these are the instructions I typed into Plotly Studio. And this is it pretty much here, highlighted in blue.
Wait, we can't see it. We only see the dashboard, Mike.
Oh, okay. Let me fix this. You haven't seen that, okay. I was trying to reshare.
Stop sharing.
Yeah. Okay. Let me go back to share. I'm going to share my full screen here. Oh, and I see. Okay, I wasn't sharing. So, this is the actual dashboard.
Yeah.
And you're seeing the let's just read right now. Class size trends over years. Yeah. Class size distribution. One thing I noticed from this data is it steps up at 15. So the class size number and how many there are, there's a step downward as you go from big class size to little class size. I don't know what that means, but maybe
that's probably the special education, what we saw with Esther's.
And there's probably some budget issue where they don't want to have classes less than 15 outside of special education because of the cost involved. So they try to fill them up. That was kind of interesting. This is kind of like a violin box plot, and you can look at different.
I like those that have violins and then a box plot in them. It makes it even easier to read the violin chart.
Yep, and you can break this down by borough. This is Brooklyn.
Would be really useful, Mike, using this box plot and including the core subject, for instance, to see exactly what is the difference between borough and core subject.
And one thing I really like, it came up in this dashboard, but I'm doing this on my own as well, is when you have a AG grid table, these floating filters are very helpful.
Yeah.
I find that much easier to filter than the kind of pull down.
The drop down, yeah.
And I try to make these tables where I put a floating filter only on the columns that are likely to be filtered, if that makes any sense. But sometimes
But
you get a lot of.
here you put filters on all the columns.
Well, I didn't put it there. Poly Studio did. That's fine. But
okay.
When I do customize one, usually there's some columns that you wouldn't really typically filter.
Yeah.
But
that's actually a very good point, Mike. I didn't really think about that. Like, because you could, if you wanted to, all these columns are make sense to filter. But the way you do it makes a lot of sense. Like, okay, this column, I don't want the user to filter this because it doesn't make any sense. For example, maybe it's a column that has all the same data. There's no filter needed. You can just go to the data card in Poly Studio and say, hey, in the prompt, don't add a filter to this column.
Yeah, and in the thought of like data cleaning, which is something I put a lot of effort into, if the column has all the same data, I usually just get rid of it.
Okay, yeah, that makes sense.
But
needed.
That's very helpful. And as I mentioned earlier, sometimes I want to have a single column table as a selection. Sometimes I have hundreds of things to select from, and it's too many to have a pull down menu. And a single column -AG grid with a floating filter is a very effective way to, just make a selection and then through a callback filter other visualizations.
It's like a fancy drop down with filters.
Yes. Mm-hmm.
Nice. All right,
and
cool.
Kind of learning my way on this. The last point I want to say is that I'm trying to go a little further in experimenting with not only how to customize this Plotly Studio output, but how to take the code out of Plotly Studio and make it like my own. And of course, once you customize the code, you don't really want to overwrite it with a new Plotly Studio generated dashboard. Right. You want to, so I'm trying to go further on that. I did a separate task this week on a Chris Parmer's show and tell thread where he generated a beautiful Sankey diagram. And just for the heck of it, I took that code, saved it as like an open source format, and in 50 lines had a beautiful Sankey. And it's only like the second time I've made a Sankey diagram. So
I saw that Sankey diagram. It wasn't impressive because you changed the colors, so now it's very clear what goes where.
Really?
Yeah. And the key thing was I took Plotly Studio's code and made it an open source, 50 lines of code, no callbacks, just make the diagram, save as an HTML file. And if you asked me like 2 months ago, I would have said, I'm never going to do a Sankey diagram. It doesn't have much value in my kind of work on measurement data. I've rethought that a lot.
Good. I'm glad.
But this is where I want to go in the coming weeks is get a little bit better at customizing the Plotly Studio output, as well as keeping my own skills growing on dashboard creation from scratch.
Awesome. Thank you, Mike.
Mike, let me ask you something. Sorry, let me ask you something. Based on this dashboard, really good work. What is your major insight that you catch from seeing this data?
That's a good question. I'll tell you two things, Alex. The big one that you stumbled on is like the 1 year is very low. That's not really an insight into New York City schools as much as it is into how this data was created. There was another one, and I think you put up that showed the distribution of math versus other subjects and how the math kind of drops down in high school. I was sad. I was sad to see that, actually. Not so surprised, but hopefully these dashboards will lead to reshaping resources. But I don't have any brilliant insights from this, Alex. I mean, it's mostly the same as all the dashboards, but The class size is pretty consistent. That surprised me. There were several visualizations that compared class size by borough, by this and that. And they also hover around like 20 to 22 in that region. I would call that pretty consistent.
That's an insight.
Yeah.
The similar class size is an insight.
The other thing I wondered is, I assume these are all for the New York City public schools, I believe.
Yeah.
Okay.
It would be interesting if they had private and public school that you could, group by
and question,
or even by zip code. I'm sure we would see a slight variation in class size if we compare between zip codes, where there's
that would
larger population or smaller populations.
It's an excellent idea too.
Okay, Alex, do you want to show us what you have?
Can you please, Aaron, share
screen? Yeah, let me load yours. Poly Studio. Am I doing the? You posted two. Which one do you want me to? Okay,
no. Whatever you want. Yeah, I posted two because I wanted to to practice with Plotly Studio. So.
But Alex, I can't. That link is not working for me. Maybe it's my computer. New NYC Educational Distribution Plotly.app.
It's not working.
I'm getting a failed. Safari can't find the server. Did did the name change slightly? Did you change the name?
No.
Let me show you what I get. Where are we? Let me show you what I get.
Weird.
Okay, so look, Alex, when I'm clicking this one, right? This one you want to see?
Exactly.
So look what happens.
Safari. Safari server. Weird. Let me try here. Well, if you want, I can share screen.
Yeah. Share your screen.
Okay.
Are you able to load it on your internet?
Let me see. Let me see if using my Plotly cloud. I open it.
Because I was able to open it a few days ago. When you first posted it, it worked.
No, I'm having an issue with Plotly Cloud too. Very weird.
Mike, what you showed us was on Plotly Cloud. So for you, the cloud was working, the app was working?
Yeah. I mean, I found times when you may be up against the limit of dashboards. And I noticed that when you deploy, it doesn't erase the previous version, but it just makes it inactive.
Oh, yeah. Try that, Alex. If you have more than 4 apps, it might
three. It has 3. But yes. Well, if you want, I can share from my local server.
Yeah, let's do that.
Okay. Can you see?
Yes.
Perfect. Well, basically, what I wanted to do, as usual, try to use, in this case, was isolation forest. It's not the first time I use it. To see exactly, to find any pattern or see hidden pattern in this case, or see is exactly the data showing us something interesting, basically. No, obviously, if I can find any interesting, well, the app is built, and I can try it with other data. That's the main idea. Well, basically here, what we have is I built isolation forest. And basically here we have a dashboard identify NYC district with universal pattern using the data from 2010 to 2015 in student to class rating. Basically, here we can see exactly the selection I have and right on items with you can select the year here with a detection sensitivity that go from 5 to 25%. Basically, this card what says that exactly the number of districts analyzed that is in the data, the number of outlier using 10%. If I set to 5%, is decreased to 2. If I go 25%, you can see 8, and this is basically the idea of sensitivity. Here, then, here also we have the percent of outlier based on this sensitivity selected. And the score, this score is the score anomaly score that the function that use calculate to exactly split what are or classify what are pattern high or what not. Okay, and here these are the critical cases that are the higher values of outlier score that I said, high severity outlier. Well, this chart, what this chart bar shows us, basically shows us the borough and how many each borough, how many districts have, and how many. If you hover on, you will see how many outlier for in this case that we have a 2013, 2014, 2015. We have 4. 2 belong to Manhattan, 1 for Brooklyn, and the other one for Queens. And here, basically, what I try to highlight in this chart, in this table, was basically the 4 districts that high severity pattern based on this data. And here we can see the average class size, all the variable that the model, that the algorithm take into account to classify is high severity or not. And you can see basically, for instance, some number can highlight, some number can pay more attention than other. For instance, in Queens, the student class 28.5%, and basically the average class is 22, and more or less that this the information we have here. And finally, here we have the deep dive analysis where we can select one of the districts. Here we have the 32 district, and we can select here with this within this year, when this detection sensitivity it change, is dynamic. If you put, if I put higher, we will hear higher value 8 or 10, and we can see here we can select one, for instance this in Manhattan, and it deploy some the information that I mentioned above, basically exactly all the information regarding this district that year. And also you can see the student distribution by course subject. That is interesting. Here unfortunately I made some cleaning and some in order to put together math, social studies. Here I don't know what exactly it is, but it's important. I wanted to get rid of
part is just like empty data. You just have to get rid of it.
I don't like it because this is very when if I did it, it's Core Studio, I would lose a lot of information based on, for instance, I did a cleaning, I did an EDA and get rid of more than the total data is about 17,000, something like that. Exactly. I get rid of 20,000 more or less.
Oh, that's a lot.
That's a lot. And also, but I did before that, I did an work. Basically, I am going to show you here in Jupyter Notebook. basically to see exactly how the impact was eliminating all this data, and the impact was minimal. So what the reason I decided to do it in that way. When I show you in the forum the heat map I did, well, this is part of the exploration analysis I normally do to see exactly. Well, basically here, then also we have the distribution among programs, class size among programs, to see exactly. Interesting here is that, for instance, we are talking about 2014, 2015. If we change the year, maybe look at how this dynamically change. And also some of the districts that one year where there are, if you look at in deeper, one district that one year or one period of year was critical or was with problems or have this pattern high. In the other one, no.
Oh.
Sometimes that's interesting. That was the main idea to make this to look closer to see what happened here, what was the idea of this, and basically this is what I built. I designed it. Basically, it's a tool to exactly deep in or try to understand some of the, I don't know, maybe variability. I don't know, it's important, or maybe you can find some hidden pattern. It's important, it's interesting to mention that, for instance, I have here the depth prepare anomaly data. This is the function that made the magic, basically. Here you can see that
Right.
metrics, the
Alice,
metric
is
that
sharing a different screen.
you can see it.
We can see the dash app, the app on the cloud, or your app, but nothing else.
Sorry. Well, here, basically what I trying to tell you is that basically here we have the anomaly algorithm take into account different district metric, basically the normal, and also a new ones that let's say a district a student per class, for instance, that is doesn't we don't have here, and it's very important to make it I calculate it, and also a class size variation. Class size
Okay.
variation is interesting because we can measure a class size standard deviation divided by class size mean. You can have a variance,
Okay.
let's say in that way, and it's interesting. And that's it. I don't know if you have I going to stop.
No, no, don't stop. Don't stop.
Yeah, yeah.
Okay.
Alex, I have a couple of questions and comments. This dashboard is one you wrote this from scratch instead of Plotly Studio?
It's good. I did it as a dash app. Is that the question?
Yeah, as Dash App. Right.
Is
Outside
that
of this is not Plotly Studio, right? But
no, I try to do it. I
no.
try. Normally I do it upside dash app always, and try to make a prompt to try to exactly do it in to, let's say, using Plotly Studio. I know right now. Yesterday I see a video that Adam did about Plotly Studio, and I get one point that is very important. Exactly how I can make these changes.
Modify. Yeah.
So
Yeah.
Okay.
next
Well,
time, next time.
I want to
Eh,
say this, you did an excellent job on it. It is really nice appearance. It looks very useful. Adam made a comment that it would be nice if we could group these by zip code, for example. And you grouped it by school district, which is probably the next best thing because zip codes don't exist. And I like that thought from both of you. I just eliminated that information, but maybe that wasn't a good decision. But when you start looking at where you've got outliers in specific districts, that can give somebody a reason to go look at those instead of focusing on a full borough-wide or full city-wide data. I think that could be really, really useful. But the appearance of your dashboard is really outstanding, Alex.
I think, thank you. I use Das Bootstrap and the Solar template.
And let's face it, in the real world, that really matters, because if you have people running your dashboard, they're going to praise you or criticize you if based upon clutter, appearance, readability, usability. I think you hit the nail on all those fronts. Very good.
And what I like, Alex, about your type of dashboards that you usually build is you go beyond the visualizations that one builds for other people, which are very helpful, but you go beyond. You use your knowledge of machine learning, supervised learning to actually detect, like you do here, outliers and give more information to the user that can maybe read a scatter plot or a bar chart, but also allows them to detect anomalies. So instead of the user looking at the bar chart, where's an anomaly here in the bar chart, or another scatter graph or a sunburst with the colors that I made, I automatically extract all those outliers for them, and then they can, like Mike said, they can just tackle the schools that they need right away, or just look deeper into them. So that's very helpful how you make your dashboards.
Thank you. The idea, I like it to exactly go deeper. And basically, well, as I said, it's like experience, maybe, are the knowledge, many years working, so maybe, and machine learning, this type of analysis, let's say in that way, this type of algorithm is not just I build, and also for another type of data is useful to use this kind of approach. That's the reason why I take the time to do this type of job.
So, Alex, building on top of that, like if I was working in the Department of Education in New York City and I wanted to use your dashboard to help me better understand what schools and districts to look deeper into, what would you recommend is the level of sensitivity that I should use?
Well, basically, it's an excellent point. First, I would, because of the districts are smaller, let's say in that way, I would use 10, starting with 10. We can go further here to see exactly, but here, if we use 25%, for instance, we have all 8 outliers detected with higher sensitivity, and you will see here the difference. But also, it's important to see exactly this is one of the important things, the slider of the year. Let's see, if I put 28, look at how they change. And this is important. This is important because you will see how well this one, what in Manhattan change, this change, and this change. What are these districts? Well, you go here down and detect it here, the district number in Brooklyn, 22. Oh, look at the difference. What is the difference? So you can go deeper if you call higher base, maybe all. The idea is, well, it's not a problem right now, but maybe it's a point of attention to see, well, in the future, it's a warning. It's a warning. In the future, we don't have.
So, Alex, let me ask you a question. Go up to the sensitivity, please. The range bar.
Here.
The slider, So if I'm a city employee in the Department of Education, and I have a very limited amount of time and maybe budget to look into the most concerning schools or the highest outliers. So for that, I should probably start in the lower range, in like the 5 or 10%. Okay.
Oh, 5%, correct.
Okay.
Correct. And
so
also
both the highest priority schools, and then
That's the reason. It's a good question. That's the reason I put here the priority alert critical outlier. exactly to answer your question. And also, if you look at, well, the District Queens, District 26, look at here, District 26, here, okay, these are the problem that we have. They have the type of class the class size and with program, etc. And also, if we do the same exercise here, well, here is along the whole year is classified as pattern high. This is obviously this is a point of attention because along the 5 years it has been in pattern high. That's the main is what I do. That's the main thing of building or create this type of tool.
Awesome.
That's it.
All right, Alex, thank you so much for
Thank you for your question and for your time.
Yeah, beautiful.
I love it. Alex, I cannot think of a better way to spend this time. So
thank you.
Beautiful. Thank you. And thank you, Mike, for showing your data app to us as well. I am going to publish in about an hour the next Figure Friday, week 34, which is going to be on a data set from Montreal. It's going to be the metro system in Montreal. So it is going to be interesting because it's going to be in French, although I do provide in the repo, we'll provide also the English translation. But Alex, I think you're going to love this, and Mike, you're going to love this data set because there's a lot of numbers to dissect, right? Incidents, train lines. I think also there. What are the how many are on time or less on time? And I don't think we've ever done like a subway system data analysis for Figure Friday. Well, especially not in Montreal. So let's analyze that. That means a lot to me because also Plotly headquarters is in Montreal. So hopefully we have some data apps.
Excellent.
I spent a week there riding those trains between Les Plateaux and Griffintown. And the thing that was remarkable to me, other than it is an excellent subway system, is hearing the pronunciations of each station and how different they are from the way I would pronounce it, as I don't have a French background. But what a great city. That's really fun.
Yeah. I don't know Montreal.
Well, now you're going to get better after this data.
No, I don't know. I don't know Montreal. My wife, wife's Toronto. She knows Toronto.
Oh, okay.
It's a bigger city. I would like to go there.
All right. Alex, thank you so much. Esther,
thank you.
You're watching us. Thank you for your data app that you presented that I showcased at the beginning. And I'll see. Don't forget, folks, if you have time, next week is there's several meetups in person in North America, and Montreal, Toronto, New York City, London, and Raleigh. But we also have our hangout, on with Martin from the Czech Republic, who uses Dash and Plotly in his in the bank where he works. That's going to be on Wednesday at noon Eastern time. And then on Thursday, we have our Plotly meetup, our virtual global meetup, where we'll just give updates and showcase a few Dash apps.
Perfect.
Great. Thank you, Adam.
Thank you. Bye. Have a nice weekend.
Everyone. Bye-bye.
Bye-bye.